Okay, there we go. Let's start off from where we left off. So we're at the plotting time series data on the PyPlot lesson. So we're going to look at so time series data, but effectively we're looking at line plots. So the first thing we're going to try to calculate the number of counts per year for each species. So I'm going to show you two ways to do this. But so the first way we're going to do it is using Pandas to kind of group our data and then plot that data. So we're going to need a new yearly counts data frame. So and then we're going to use our group by functionality to then say group it by year. Oops. And by species ID. Oops, let's fix that. And then we want the species ID. And we want the count. So what that'll do, it'll group our data frame by year and species ID. It'll then just take the species ID and return a count per year for that species, as we've seen before. So we can output that. You can see we've got our year, species ID, and then a count. And we've got that for all the years. To put this into plot 9, what we've got to do is we need to reset the index, because you can so if we put this currently into plot 9, it would complain that it doesn't operate on a series. So I believe what we've got here is currently a series rather than, I believe I can actually probably show this. This is a Pandas series. Plot 9 will only operate on data frames. So by resetting the index, it now looks like this, like the data frame, with our year, species, counts as actual columns. And actually, if I return to the type of this, we can see it is now a data frame rather than a series, which is what plot 9 wants. Then we can go into plot 9. We can take our data, which is now yearly counts. We can specify our mapping. Which is going to be the year along the x-axis, and then our counts along the y. So again, actually I shall, just so we can see it, we see our data frame, year, and then our counts column. And then we're going to output that using the line geom. So geom line. Oh, what did I miss? Mapping equals, that will be the problem, which might then be, there we go. So this doesn't quite do what we want it to do, because for each year we've got multiple counts. We've got one count for each species, so it's kind of plotting all of those at once. So what we need to do is group our data. So again, we can use our color specifier in the mapping to say that we want to group our data by color using the species ID. so our species ID column here. So then when we run that, we can see we've now got year on the bottom, counts, and then we've got it grouped by color using the species ID. So we've got one line per species. That is the standard way of doing it. There is another way you can do it using plot9. We can actually take our original data frame, so our survey's complete data frame. We can put it into here, and I believe, actually, I haven't actually tested this one. I tested it using something slightly different, but I think this will work. There we go. So what we can do is we can take our original survey's data frame. We can still say we want the year. We can say we want to color it by species ID, but we can say actually we want the stat function to be the count. So we can get plot9 to go, okay, take these groupings and then plot it using the count. I believe, you can, so plot9 has these utility things. You could also use it to do things like, say, along the Y we want the so we want to plot the weight, but again we could use the summary stat in order to plot the mean of the weight per species. So this is quite nice and easy because we're not having to mess around with pandas. We're doing it all from our survey's complete data frame in plot9. You can see we've got the average weight per species plotted here quite nicely across time. If you're trying to do something quite complicated, you're probably best doing a lot of your pre-processing using pandas and everything that Rory and Laura talked about previously, getting your data frame set up to then put into plot9. If you're doing something a bit simpler like this, then you can do some of that using plot9, but it's sometimes a little harder to find out exactly how to do what it is you're trying to do. So that's briefly talking about time series plotting, and then we'll just finish this section by going over faceting. If you have any questions at any point, do just plot them in the chat and we can go over them. So what we might want to do is, instead of plotting lots of groups on the same plot, we might want to group them somehow but do them on separate plots. So plotline lets us do that using something called faceting. So if we take our same plot we had earlier, so here we're plotting the weight against the height foot length, and we're grouping it by species. And we're just plotting that as a scatter plot. So as we had before, we can take this and we can use our facet wrap layer. And then we can choose a column to do this over. So here we're going to do it by sex. So what this is doing is it's still plotting the weight versus the hind foot length, and it's still grouping by the species, but we've got our facets, which are here, where we've got two plots which are grouped by sex. So this left one is just the female animals that have been surveyed, and the right is our male ones that have been surveyed. So that's nice and easy. Just by adding this single layer, we've got this. But we can do this for any categorical variables that are in our data frame. So we can change this to, say, plot ID. We want to just output this differently for each of the plot IDs. And we can see it's nice and easily gone through. We've got our 24 plots, and we've got a separate plot for each of them. The facet wrap kind of layer, this geometry here, it extracts plots with an arbitrary number of dimensions, and it will just kind of adjust to make it look fairly sensible. On the other hand, you can specify exactly using a different facet, which is a facet grid. Actually, I will duplicate this below. And again, there are a few different facets which are in the Plot9 documentation. So the nice thing about this is we can now do it on more than just one categorical variable. So we could actually do year and then this tilde symbol using our kind of the kind of function notation, where we have rows on the left and then columns on the right. So we're going to have year in the rows, and then in the column we're going to have sex. So we're not going to do this on the whole complete data set, because this will be, we have a lot of years, so we're actually going to first filter it. So 30,000. So what this is doing is it's saying, our survey is a complete data frame, take the year column and only return the ones that are in 2000 or 2001. So that will take those, and then we can just change our data in here to use this survey 2000 data frame, and we can then plot that. So you can see we've got in our rows we've got the years, so 2000, 2001, and then in the columns we've got female, male, and we could have, you may want to format this differently. You can also do, I believe it is rows, yeah. So you can say rows equals year, cols equals sex, and that will do the same thing. It's just a matter of preference whether you want to use that formula notation. I think this is a bit more explicit with what's going on, but it's kind of personal preference. Yes, so we'll take a brief moment to go over the faceting challenges. So where's my, there it is. So what this is going to ask you to do is create a plot for each of the species that depicts how the average weight of the species changes throughout the year. So use the faceting to create a plot per species, and each plot should show the average weight across the time, and then see if you can compare the weights of how males and females has changed by creating a separate plot for sex and individual color assigned to species ID. So I'll give you a few minutes to work through them, then we'll go through them. I might be a little bit speedy so that we have time to get through matplotlib stuff as well. But yeah, as usual, any questions, do let me know. Okay, let's quickly go through this. So the first one was aiming to create a plot for each of the species that shows how the average weight changes throughout the years. So the first thing we can do is we can create our data frame grouped by year and species, get the weight, and then calculate the mean weight. So again, we're using Pandas to do all this, and then again the reset index in order to make it a data frame. Again, we can then create our plot line plot. So oops. I've done that in order. line.gt plot as our data, yearly weight, setting our mapping. Yeah. Then our geom line, and then we can do our facet wrap over the species ID. What have I? Okay. So as you see, we've now got a plot per species, and in each one it's plotting the year by the weight as we kind of calculated using our data frame. This warning you're getting, I believe, is just because there are some species that don't really have data. So it's complaining that that is the case, which is reasonable, but you don't need to, that's fine for this. So then the next one, where we want to do very similar, but we also want to compare the we also want to do the facet using sex as well as just the species ID. So we can add here to our grouped data. We can also group it by sex, and then in here we can add the year, weight. Then for our color we can add the species ID. Just going to reformat that. There we go. Yeah, here again, it's just use the brackets, and then you can do these all on new lines. Color, species ID, and then for this time our facet wrap is going to be using sex. So here we can see we've got our facet wrap, sex, female and male, but then we've also, as well as that, got our grouping by color by the species ID. As you can see, those are effectively different ways you can group your data in your plots. Very quickly go through some other customizations you can do. So this is going to just plot as a bar chart that has our year data at the bottom. Again, factor to say this is categorical data. We want to treat it as categorical data here. We've got our bar chart. But you can see that the years at the bottom are, you can't read them, they're overlapping. So we're going to use the, define our own theme in order to change how they're displayed. So we're going to do this. So first off, we can take we'll just generally change the theme to this black and white theme, but then we can also define our own custom theme, and we're going to we want to change the axis text on the x-axis. I'm just going to equal to this element text. So this element text function is kind of the thing we use for any adjustments we're going to make to a text element, and we want to set the angle to 90. So we can see that has taken the text on the x-axis and is rotated 90 degrees, so it's now legible and we can read it. We can also create custom themes. So if we want to reuse a theme, we can set a custom theme, which we're going to equal to this P9 theme, and we can set it such that the x-axis text and the text, we can set the color, we can set the size, we can set the angle, We can also set the kind of horizontal justification. So what this is doing is saying center it, because that's 0.5. That's effectively what it's doing. So that's our theme, nice text, grey, size 10, angle 10, horizontal justification. We can also do the same, similar for the Y, but we might want this to be different. So size is 10, so we don't want the horizontal justification for this one. And then down here, rather than doing this here, we can just use our own custom theme. So here we can just go my custom theme. That will apply everything we've defined up here to this plot. So if you're doing multiple plots and you want to define one theme which you apply to all of them, this is a good way of doing it. So as you can see, these are now, they're a slightly lighter grey colour, and they've been set, the size has been set, and everything we did up there. There is a challenge on here to do some customization. I'll leave that for you to do kind of in your own time. If you do come up with some customizations and some things or rendering problems, do let us know, but I won't do specific time for that, just because I'm aware of time. And the last thing I'm going to show you is there are ways you may want to save your plots once we've done them. So here, if I assign, rather than outputting it, if I just save my plot to a variable here, so it should be saved to a variable, I can then go my plot.save. So once you've got this plot saved, there's a .save method. I can just call it my bar chart or something. Then you can also set the size you want it to be. Width, height, and also importantly the DPI. So that sets the actual quality of the image. So the kind of the resolution. The higher this is, the more resolution your image will be. 300 is fairly standard. Saving 10 by 10. Okay, I think that's just saying that it's done it. If I actually go to into here, we can see it's been saved. So that was my notebook I was using, and then this is the actual bar chart, and we can see it's just been saved. Quite large, that's okay. So yeah, that is plot 9. The key things are that kind of layered approach, and you can add all your attributes like scales, your themes, your labels and stuff, just using that layered approach. Are there any specific questions about plot 9? And if not, we will move on to talking a little bit about matplotlib. Okay, I think we shall move on then. So plot 9 is based on a lower level Python library called matplotlib. It's a very commonly used library. We can import it. It's usually imported like this, using part of it called pyplot. So we can, as usual, we can take whenever we. So this is using the pandas plotting, which we saw earlier. So we're reading in the CSV. We're then using the pandas plot function to do the input length and weight, and the kind of plot we want is a scatter plot. And then you show that by using this plot.show. So this is so surveys here is a data frame, and it's got a plot method, and we're saying the X and the Y we want, and then the kind of plot we want. And this is, again, it's all built on matplotlib, which is, you can tell by this plot.show is calling this matplotlib pyplot functionality. Matplotlib takes a slightly different approach to plotline, rather than plotline having this kind of layered approach where you build up on layers of your graph. Matplotlib is object based, so you have a graph object, and then you use various methods on that object in order to alter it. So we're going to show this by first, we're going to start by importing another library, which I don't think we've used yet, called NumPy, which is used a lot in scientific Python programming. Basically it's a very fast, it's a fairly fast array library. So we're going to use it to generate some sample data here. It's got a module called random, which we're going to use to create a normal distribution. So 0. So our value is going to be between 0 and 0. No, hang on. What is normal? No, that's not working. Let me just look it up. There we go. So we're using the random module. It's got a normal function. 0 here is specifying the mean of our distribution. 0.1 is our standard deviation, and then size. This is the number of data points we want to generate. And then we can use matplotlib, so plot as we imported as above, and then it's got it's got lots and lots of different functions, but we want to make a histogram, so .hist, and then we can just plot this sample data. If you're not in a Jupyter notebook, you would do this, and then you would do .show, sorry. And it will show your plot. You can do it in Jupyter Notebook as well, and it's probably good practice too, just because you'll need to use it when scripting outside of a Jupyter Notebook. So as we can see, we've got a histogram plotted, and it's done what you'd normally do. It's a count in terms of how many data values are shown. NumPy also, I'm going to go a little off piste from the course we're working through, but I'm going to say you had I'm just going to do this as a list. So you had two lists, A and B. There are other types of plots you can do. So you create a bar chart, so I could just plot my A list as plot.bar. Oh no, height. I've got to specify that. I'm going to show you this later. That's not the right thing to do there. Yes, I know I've missed that. Don't worry about that. I will show you that later. The next thing about Matplotlib is we can take subplots. So the next thing we'll go through is we can create this is how we'd initiate an empty figure and an empty axis. So rather than doing plot.hist with our sample data, we can define our figure, we can define our axis, then we can take our axis and also call the .hist method on it and plot our sample data here. And again, you can still call plot.show in order to show it. The thing this lets you do is you can actually define multiple subplots. So I could, for example, say I want two subplots. What I'd actually do is this. So I've now got my figure and I've got my axes, and then I could take my first axis and plot my data. And you can see I've now got two plots. So it's rows first, then columns. And the first one has my sample data on it. My second one does not. It's currently empty, but I could take my second one, axes.that.hist, and we could also plot our sample data, but we're going to double it. So, except it's a histogram, so it does the count. So it doesn't actually show that. But you could do different things on each of the axes, and here you can define your rows and your columns. So I could make this. I've done something. Oh, because it's an ND array. Yeah, fine. I'll stick to simple. You can create your multiple axes. You can do multiple grids. You would then need to index your axes. Say you want the 0th one by 0th one. You'd have to do that instead. You've got to do your 2D indexing, which is a little beyond the scope of this course, so I won't go into that. In our histograms, we can also define the number of bins we want. So here we're providing the sample data, and then this here is the number of bins we want to put into our histogram. In what degree do we want to chunk up our data? This next bit will go a little bit more into having multiple axes. So we can take what we've got already. So we've got our plot.subplots, which creates our figure, and our axis, which we're going to call axis 1. We're going to plot our histogram, and then we're going to add labels. So x1.set y label density, and then x1.set x label is going to be the value. So again, similar to how in plot 9 we set our labels by adding layers, here we do it similarly, but we take the actual axis object and call a method on it. We can then we can just here call plot.show, and it will show our histogram now with our value and our density labels on the axis. But we can also we could show another axis on top of this. So this is taking a beta distribution, and then we want to plot this on a new axis. So we can define an ARCHER2. We can take our matplotlib figure and we can say add an axis. We need to tell matplotlib where we want this axis to be positioned. So this is taking the bottom left corner, I believe. Sorry, it's left bottom corner and then the width and the height. That's what it is. So that's our position, and then that's our size. And then we can say ARCHER2.list draws. And so now when we plot it, we now have this second axis here is kind of just on top because it's completely separate. We could move it wherever we wanted. So say we wanted it to be to the left, we could actually change this to say minus 0.5. This is probably going to go quite far over to the left, but now we've moved it off. And we can generally position this wherever we want. We could add our own labels to the axis in the same way we've done here, titles to it, all that kind of thing. And you can kind of see how matplotlib, there's a lot more you can do. It's a little bit more complicated, but you've got very, very fine-grained control over what you can do and the kind of plots you can create. So that's fine. There is a challenge to create your own plots using some. Oh, can you show the subset of your data in the same way? What do you mean by that? Do you mean plots just a subset of my sample data? Oh, okay. If in terms of your ARCHER2, if you wanted it to use it to, yeah, in theory you could. So we could take our sample data. So we could say x2, we want to plot the sample data again. But then we could say ARCHER2 dot set, is it xlim, I think. Maybe just xlim. Give me a second. Yeah, set xlim. And then we could set that to say, say we just want to look at minus 0.2 to minus 0.1. So then when we do the plot, you can see we've got our axis 1 here with the whole data, and then we've got our ARCHER2, which is all over here at the moment, but you can see it's only going from 0.2 to minus 0.2 to minus 0.1. Cool. So yes. So there is a challenge to do some drawing from a distribution, which we'll get to at the. I might leave that to do at the end if there's some time. What this we now go on to is you can technically link you can create your plot in Pandas or in plot9, and then do further edits using matplotlib. So for Pandas, this works quite well. So I'm just going to copy and paste this time and walk through it. So here you can see we're creating our matplotlib figure. We've got our figure and we've got our axis 1. And then we can create our data surveys. We can call plot. We can say we want the hindfoot length, the weight. It's a scatter plot. And we can then set our axis. So we can say the axis we want you to plot this on is this ax1 object we've just created. But then later on with matplotlib, we can do what we'd normally do. We can set the x label. We can do things like, so this is the tick param. So this is, so the ticks are these things here up the axis. We can set the size of them, some padding to make them display how we want them to display. We can also take our figure object and we can set a title. That's this subtitle method. So if we had multiple axes, that would be the title for the whole thing. You can also set titles for individual axes if you wanted to, and again set the font size. But it means when we generate that, we've got our kind of core Pandas plot that we generated, but also with our customizations we've done using matplotlib. So in that sense, it's quite powerful, and we can do the Pandas can do a lot of the kind of trickier bits in terms of setup, and then we can do the customization. You can do the same with plot9. However, in doing this, it doesn't work. I wouldn't recommend doing this. Not really. Because the function you would use is myplot.draw, and what that returns is a matplotlib figure. So which you can then access the axis for by doing that. So that will get us the axis. So now we've got my plot version, which is our matplotlib figure. We've got our P9 axis here, which we've got. And then in theory, we can then do as we've done before. We can set things like the X label. In fact, I'll add all this. We can set our tick parameters, our title. Most of these, if not all of these things, we could do in plot9 anyway. And as we showed on the previous exercises, when we plot this, however, you'll notice we've set the X label, but it's gone over the top. And this is generally what I've found. Plot9 does use matplotlib, but it doesn't necessarily use it how you would expect, which means when you go to do the customization, you may not see what you want to be seeing. Plus, actually outputting and displaying the plot, I had difficulties with. So Pandas, absolutely, it probably does work, and it's probably a sensible thing to do. Plotline, if I would stick to just using plot9 and do it all in plot9, or do it all in matplotlib / maybe Pandas. Yes. So because of that, I'm gonna kind of can we do this? This is using plot9. How would it for time? Yes, okay, we've got time to do this. We'll do the challenge here is the Pandas and matplotlib, which should work fine. So we'll do that. If we can go through that challenge, which I'll bring over. Oh no, this one is still actually on the wrong page. So this is saying to load the stream gauge data. So I'm going to actually put in the some helper text. I'm going to walk through the first aspects of this because I didn't quite cover it earlier. So there's another data set which you've got, which is this Boulder Creek text file. So we want to read it in using the read CSV method that we've been using previously. However, this is a text file, so it's got, in fact, I can open it up here. It's got various comments at the start of it, which we don't want to read in, and if we do read in, Pandas will complain that it doesn't know how to read that as a CSV file. The nice thing is the read CSV method has some things that can help us with that. So this skip rows 27 means skip the first 27 rows. That's not part of the file we want to read. We can also change the delimiter. By default, CSV files have a comma as a delimiter. This file doesn't use that. It's got a tab. And we can also name the columns, which I don't believe the text file, it does, but it gives them different names. And we want to, if we might go, actually, there's better names we want to do. And then there's also the date time column. Pandas.date2datetime will reformat that for us into a sensible datetime format. I'll leave the rest of the exercise for you to do, if I can position that so you can have that as a good starter. But the aim is to create a line plot of the discharge data using Pandas, link it to your matplotlib axis, and then do a bit of editing and create a second axis that displays the whole data set. I will leave that for you guys to do over the break and maybe a little bit of time afterwards, and then we'll go through a solution. I think Laura is also going to put a feedback link into the chat, which would be really useful for us for you to fill out before the end of this session. It's really helpful for us in terms of after this course, any feedback on how it went, but also looking forward to running it again with other people, how we can adapt it, change it, improve it. So yeah, any feedback you have, positive or negative, constructive feedback is always welcome. So yeah, we'll be back kind of about 2:15, maybe just after, and we'll go through this exercise. Yeah, cool. Okay, I think let's go through that example. Hopefully going through it will make some of the stuff in general we've been going through a little clearer with how it works. But let's go through it. So once we've read in our if I don't have any particular questions doing this, then yeah, we can cover them. But once we've read in our data here, we're going to we've changed it to a date time format, and what that lets us do is we want to plot the week of a particular flood. So we want September the 11th 2013 through to September the 15th 2013. So the way we're going to do that is we're going to create a new flood data frame. We're going to create our general discharge data frame, and we're going to say that the date time where that we want the sections of this where the date time is greater than 2013 September 11, and no, that's why. Let's do it this way. And discharge is less than or equal to the 2013 September 15. So by converting this column into a date-time format, it means we can do this comparison. So this date-time type that we've effectively transferred this into can do a direct comparison to this string, and it knows that this means year 2013, month September, date 11th. So that gets us our flood data frame. We can initialize our matplotlib figure and axis using our plot.subplots, and then we can plot this flood. So we can say flood.plot, and we want the x-axis to be the date, and we want the y to be the flow rate, and we're going to specify the axis we want to plot this on is the axis we have created. We can then do some configuration, so we can remove the X label because this is going to be our kind of zoomed in plot to just the flood, so we don't want a label on it. Well, yeah, we're not going to put a label on it. Set the Y label to remove the legend. So we can get the legend by doing x.legend, and then we can set visible false. So that says we don't, because we've only got the one data series, we don't want the legend. We can set the title. Okay. Cool. So if we plot that, oh, what have I got wrong? Oops, typo here. So this has plotted the from the 11th September to the 15th, just this flood here. Actually, I misspoke earlier. We're then going to add here. We're going to create a second axis. So we're going to go fig.add axis. As before, we'll say where we want it. So the bottom left is going to be here. And then the size of it is going to be 0.25, 0.3. So I should say these values are all effectively percentages. So 1 would be the same width as this. 0.3 is basically saying we want a 30% of the width of kind of your default axis size. Is effectively what that's saying. And then on this axis, we're actually going to call the plot function directly on the axis. So we want to plot the date. This is effectively doing something quite similar. We could use the kind of discharge.plot. This is basically doing the same thing. It's just another way of doing it. Instead of doing discharge.plot, we're going to use the axis plot method and specify the data. And the data we're using again is date time and flow rate. and then here where we have plot.xticks, what that's doing is it's going to change the xticks for all the axes in the plot, rather than for a specific axis. Sorry, I misspoke, for the active plot. That's where matplotlib can get a little confusing, because that will actually change it for axis 2, just because that's the last one that was plotted, so it's the active one in a way. And then we can show it, so we can see this axis 2 is now up in the right hand corner with the rotated ticks and yeah, with the data we specified, so that's the full length of it. Are there any specific questions about that? Okay. If not, I will just show the last thing on here, which is how to, similar to plot9, how we can save a matplotlib figure. So we've got our, here we're showing our plot, but we can go fig, so we can get our matplotlib figure, fig.savefig, and what do we want to call it? We want to call, let's call it flood plot.png. Then that will save the plot. It should do. So if I go into here, yeah, we've now got here, we've got our flood plot, which has been output here. Similar to plot9, we can also specify the DPI in basically the same way. So DPI 300. Cool. Which, there you go, we can see it's been output a lot bigger. I'm glad that's clear. You can also, you don't have to output as a PNG, you can also output it as a PDF. And matplotlib does this just by looking at the file extension you have specified. So again, you just save it, .pdf, and then you'll find in here, refresh it, there, we've now got a PDF plot version of the plot, which can be quite useful. Yes, that's everything I was going to explicitly cover about matplotlib. This is specifically a way of working with matplotlib with data frames. That's what the focus of this has been on most of the time. I'm also just going to put a link in the chat. Which I think is quite good for if you want a bit more about, because we've really only touched the surface of what matplotlib can do. If you want a bit more introduction to the to using matplotlib with different types of plots, some of the other configuration you can do, that's a good intro. It, with a caveat of, it does a slightly different approach to what we've done here. So if you're kind of quite confident what we've had here, then that's all good. Continue doing that. But this kind of shows some of the other things it can do. But as I say, taking a slightly different, less data frame centric approach. So it's a bit different. Okay, we've got 35 minutes. That should be all right. We can always, we've got a little bit of spare time at the end if we need to use it. We're going to talk a little bit about SQL. Oh, yeah. How do I specify the path where to save the image? Okay, so that's in here when you do your save fig. So I put that just in the current directory. I could quite easily, I could change where I put that. So I could say I want a plot output directory. And then I would put that in a plot output directory, and then that's the file name. So that's how you specify the path. Here, I'd have to make the directory first. because it doesn't exist. So I can make a plot output directory and then output it. Cool, great. Cool. So I'm going to make a quick poll because I'm curious. How many people have actually used SQL before, or even know what it is, to be honest? Okay, mostly no, not really. Cool. So currently we've been working with Pandas data frames, and we've been reading them in from CSV files. So they are effectively tables, but they're in text form. You've got your columns, and then you're separated all by commas and stuff. SQL SQL stands for Structured Query Language. It's a way of querying data from a database, which is a different format basically for saving our data in. And we're specifically going to work with an SQLite database, which is quite nice. It's a good one in terms of working with Python. There's a library you can use for easily reading them. You can, if you go online and search for an SQLite database viewer, you can download them, and you can find them online to software you can download to view these databases. We're going to work with, if I close these off, this in your data folder that you downloaded, there's a portal mammals.sqlite file. That's the file we're going to be working with. So I think the easiest way to do this would be to show you how you can read this data in, and then a little bit of what it looks like. So we're going to be using the SQLite 3 library. So we can import that. And so the first thing we need to do is create a connection to this, to our database. So we create the connection, so SQLite3.connect, and then we specify the path to our database, which is ultimately just a file. It's just not really a naturally human readable file. You'd need some software to look into it and make sure understand what it says. So then we need to create a cursor. So we can do con.cursor. And then we need to query the database. So I'm going to do, so our result is going to be cursor.execute, and then this part is the actual SQL query. So this is, if you're talking about SQL, this is kind of what it is. So we're going to say we want to select, and then star means we want to select everything, and then from species. So species is our table. So an SQL database can contain, unlike an CSV file, which has like a single table, an SQL database can have multiple tables. So here we have a species table, and we want to select everything from it. So that's going to be our result. And then we want to say for row in result, because we've got multiple results here, we're just going to print the row. And then we also need to make sure we close the connection. you need to close it in the same way you need to close files if you're working with them. When a file is open, you might run into problems with locking and other programs not being able to read that file, so you need to make sure you close it. So if we run that, we can see here we're printing each row, and we say each row in this database we've got, this looks quite familiar to the data we were working with before, kind of species ID, and then some information about the species in each row. So this is these are different entries in our database. So before we go much further, I'm going to show something that can be quite useful. I'm going to duplicate this. I'm going to change our query. So it might be useful for us to know what tables we actually have in our database. So there is something, so we can still have our select and select everything from, but we're going to choose a different table. We're going to choose something called SQLite schema. Now this is a table that every SQL database will have. I forgot. Sorry. So when you, I'll just close that because we're going to keep this. We'll keep this connection open for now. We'll close it later. So once you've got your result, there's two methods you can use. You can use fetch all, which will just output as a list all the things you've found. You can also do fetch one, which will just output the first one, as you can see here. We'll do fetch all for now. So this SQLite schema, it's got a few entries. So these are the tables we have. So this first one is saying it's a table. It's called surveys. You don't need to worry too much about the rest of the stuff. That's kind of specifications about the table. We've got a surveys table, we've got a species table, and we've got a plots table. We might also want to find out information about the table itself. So another command we can do is pragma table info. So say we want to find out about this species table. We can say we've got this table species in it, so each row is going to have this information. It's going to have the species ID, it's going to have the genus, it's going to have the species, and it's going to have the taxa. So that's just information about each of the species. So as you can see, when we output the species, that's what we were getting: the species ID, the genus, species, and the taxa, which I think is like the whole overall family. It's not too important for this. But you could do that for the other tables here that we've got here as well. So surveys, which you can see have record ID, month, day, year, plot ID, species ID, sex, height, length, weight. The important thing here is, so each table needs to have a ID that's unique per row. So here in this species table, we've got a species ID. We've also got a species ID in our table, in our surveys table, which means we can link this data. That's a kind of a key we can use to go. In this survey, it's saying, oh, I've seen this species, but if we want more information about that species, we'd have to go into our species table. And we'll see kind of how that works a little later. So let's do a little bit about writing some queries. So with our connection open, we're going to make a, actually I will just also do this for the plots table, just so we can see what's in it. Because you see also this surveys, we've got a plot ID. And so this might tell us if we wanted more information about a plot, we'd go into here, which has information on the plot ID and the plot type. I should say this also tells you what data type each of these are. So we see a plot ID is actually just an integer, a big int is a SQLite specific type text here. You can see we've got some floats, but generally they behave as you'd expect. So we want to select some data from the plots table. So we're going to do select, but instead of selecting everything, we're going to specify a column. So we can specify plot ID. And then we can say from, and again, we want to specify what table. So from the plots table, where the plot type equals control. So what this is saying is we want the plot ID column, we want the table this is from is plots, but then we're putting a condition on it. We only want the rows where the plot type is control. And except I need to use different quotation marks, because otherwise you can't have, if you're using double quotes, you can't then use double quotes on the outside as well. It won't work. And then we can do the fetch all. And as we can see, this returns plots 2, 4, 8, 11, 12, 14, 17, and 22. So they're all our plots IDs where the plot type is also control. As another example, we could select the species from our table species, where the taxa equals bird. And then again, it's using this as an example to do fetch one. And in fact, we don't need to assign the result. We can also just say cursor execute this and then cursor fetch one. So that's returning the species. And again, we can use fetch all, and that will then return all of them. Okay, so that's a very brief introduction to how kind of SQL querying can work, how we can get data from this. But we might not want to be working in SQL the whole time. And what we can actually do is we can read data into Pandas using an SQL query. So we create a data frame df, and then pd, so pandas.read SQL query. And then we go select star from surveys. All this capitalization of things like select and from, they're not always strictly necessary, but it's good convention in terms of in SQL. It does make it a bit clearer a lot of the time what's going on. So that's the query we want to do. We want to select everything from the surveys table, and then we need to give it the SQL connection that we set up. And then we can go df.head. So there we can see we've read in the surveys table, but we now have it as a Pandas data frame, and all the usual Pandas stuff that we've covered, we could then do on it. So I guess that's a question. Why might we want to store data using SQL instead of CSV? Well, one of the key reasons we might is performance. Reading and writing to an SQLite database is a lot faster than CSV. I mean, the course page links to some data, but this is the data whereby they this on the left is effectively reading from a CSV file. This middle one is then reading from a CSV file and writing it all out to an SQLite database. So actually, it's reading it and then doing the writing. But then doing the query, reading in the entire database, just using SQL, so effectively this blue one and then this yellow one, much faster. This is only a kind of cursory look at it, but in general, SQLite is fast compared to CSV files. That's the main reason, and particularly as your data grows. You might find CSV files getting a little unwieldy at times. So we've got an SQL challenge here, which is for you to have a go at writing your own queries and setting some conditions for the queries you want to read in. So you want to create a query that contains survey data between 1998 and 2001, and we want the sex observations as well as the genus and species and site type, and how many observations are how many records are returned, and also can we create a data frame for the total number of observations for all years. So that second one, you're probably going to want to read the right data into a data frame and then do the processing using a data frame. As a hint for the first one, you can do joins in the same way you can for data frames using SQL queries. So that would be if you're a bit stuck, that's a good thing to Google and look at, or ask a question, and I can probably provide some hints. But yeah, we'll go on to that, and I'll give you a few minutes to do that. Okay, I think there's a couple of people that still work on this, but I think let's go through it because it is does actually cover some new things that we've not explicitly gone over in the lesson. So we can just go. Yeah. Okay, we'll start fresh with a new connection. So we've set up our connection, we've got our cursor. Then we want to execute our command. So let's start by, let's do this bit by bit. So if we start by selecting, just say we're going to select everything from, so we want survey data. So let's take the surveys table. The thing is, we also want data that isn't in the surveys table, because we also want species data, and we also want data about the plots. So what we're going to do is we're going to perform an inner join. With the table plots, and then we're going to specify what that join is on. So that join is going to be on surveys dot plot equals plots dot plot ID. So what's that saying? It's saying do an inner join like we did on with pandas earlier. Take the plots table, and we want to join them in such a way where the surveys.plot column equals the plots.plot ID column. We also want to do similar with the species table. So we want to do another inner join, and this time on the species table. On surveys.species equals species dot species ID. So now that we've done that, let's add to our selector, because we actually only want to return certain things. So we're going to want the year because we're selecting based on the year later. So we can take surveys.year. So the way we specify, when we've got multiple joined tables, we need to specify the table name and then the column we want. So surveys.year. We also want plots.plot type. Species, we want the genus information. We also want the actual species. And we want sex. So that's all the information we want. I'm going to move this to be here. There we go. So our selectors, they're all the columns we want, and from the tables we want them. Defining our joins to get our full kind of bind table. Then we want to specify what it is we want to select. So we want to select this where surveys.year, so surveys table, year column, is greater than or equal to 1998. Oops. And so we can use our logical selectors to specify our conditions. So surveys.year is less than or equal to 2001. Then we also had another condition. So and I'll put that in brackets. Surveys sex equals M. So we're going to put that in single quotes. Or surveys.sex equals F. So that looks like you end up with quite a complicated query, and you can really see how these SQL queries can get quite complex quite quickly. But you can break down to what you're selecting, generating your table, and then the conditions with which you want to select your rows. So we'd execute that, and then we can print out our results. And make sure we close the connection. And I'm not surprised, I made a typo somewhere. Is it surveys.plot ID? It is. Surveys.plot ID, and this is probably going to be species ID as well, isn't it? There we go. And then we get our output, our query returned 5,546 records. Cool. On to our next one. So I'm just going to copy paste these just so we can get through a little faster. So here we're going to read this into a Pandas data frame. So we're going to select the year from surveys, but we're going to group it by year. So we've got this group by function, group it by year, and we've got this count function here, which is going to say take our groups and count how many are in each group. Similar to basically the same as how group by works in Pandas. And then we've got similar here. Going to format this a little bit nicer. So we're going to select the year and the plot from surveys, and we're going to group it by the year and the plot, and we're going to order by plot ascending. So we've got our surveys, we're grouping by year and plot, which was returning, and then this column, instead of just returning the weight, we're going to do this aggregate function over the groups, which is to sum the weight. But we want to make sure we're outputting with our plots in order. I think this might complain at me for not having plot ID. Yes, it is. Plot ID. Then we can see our data frame 1 is year with all these counts, and also df2 is the year, and we see the plot ID per year and the sum weight in this column. In order to do something a bit more useful with this, we can use the pivot function. So the pivot function says is getting us to take some columns, some values in our column, and make it into the actual column names. So this is saying we want to construct this new data frame with the index being the year column, the column names to be actually the plot ID, and then the actual values to be this sum weight column. So if we then actually run that, we can see we've now got the year here, we've got the plot ID across. So then rather than having this, we've got lots of for each year, we've got one entry for each of the plots. We've actually got the plot IDs up the top. And then we can do things like, that's usually a much easier, more useful format. And then it means because we've now got year as the index on both of these, we can do our merge with df1, df2 on the year column. And if we just print the head, we can see we've now got year along here, we've got our plot IDs, and we've also got our count sums. Cool. That was fairly quick, nearly come in on time. We haven't quite got to saving, creating new tables using Pandas, which might be a good thing to briefly go over. Would people rather spend 5-10 minutes going over that quickly, or do you want a little bit of a break before doing that? I'm aware we're supposed to finish at 3, so if people do need to head off, that's okay. This will be recorded if you do need to catch up later. Cool. Yeah, cool. We can spend, it should only be 5-10 minutes to go through this last thing anyway, but it's kind of important because there's no point doing this if you can't then write out to new databases. So let's go over this quickly. So if once we have our connection, we can, as before, load up the data frame. So we're reading the SQL query where we're selecting everything from our surveys table using the connection we've specified. So then we could select the data we want. So say we want to select only the data for 2002. Oh, I've done too much nesting now, I think. I'm not quite sure how I did that. So we've got our surveys 2002 data. So we can see we've got this data frame. It's all 2002 data. And then we can write this to a new SQLite table. So surveys 2002 dot, then we can use this to SQL. So just like we've got to CSV, we've got a to SQL. We can call it surveys 2002 con if exists place. So what this is doing is it's using the connection we've already specified. So this is still going to write to the Portal Mammals SQLite file, because that's the connection we've specified. This here is the actual table name. So surveys 2002 will be the table name, and we've got specified here if it exists, replace. And there's a few different values that can take. So we could append. So if it exists, we could append the new data onto the existing table. You could also say fail. So the default is that it fails. It'll just throw an error saying this table exists. It won't automatically replace your data. So we can run that. And then what we can actually do, what we could do is we could get our connection. How can you create a database? That is a good question. I imagine if I do this and I say, I'll just close this connection. So say I created a new connection, which was going to be my SQL database, .SQLite. So that's my new connection. If I then write this here, so I'm using my surveys 2002 database to SQL, but I'm using this connection. That'll now still outright, that'll still write, but if I go into my data thing here, I've now got a MySQL database.SQLite, so it will exist in there. Does that make sense? Cool. Excellent. But then what I can do is I can say oops. There we go. I'm just going to select the name property because that will tell us the useful things. So we can now see that, so from this new database we created, it's just got this surveys 2002 table. I'm not entirely sure why it's also got that. That might be an internal table it uses. But if I just run this to close the connection, and I'll just create this one again. So if I open up the Portal Mammals SQLite connection, and then do the same, you'll see that you've got surveys, species, plots as before, but you've also got the surveys 2002, and then you've got that one as well. I wonder whether that must be one Pandas creates then, I guess. Yeah, maybe that's the index being true. Or not. I'm not entirely certain, but I'm sure the documentation would say somewhere. I've not, yeah. Yes. So if you're executing one query, yes, it is. So, in terms of, I don't know why you'd ever need to write multiple SQL queries for a single execution if you're using it in this way. But say you can write SQL, I guess, script type things where you'd have the semicolon to separate out commands. Because you can use SQL. So this execute function will execute any SQL you want. So you could do this and then do in here a new command, and you can use SQL to actually write to tables or create tables, or yeah, lots of things. So you could use that would just separate out commands. You could do that all in one execute command, if that makes sense. Cool. In general, if you're writing SQL scripts, you should definitely include the semicolon. There's security concerns. Yes, if you don't, you can. Yeah, it's not really relevant to this, but you can have things happening that you don't really want to happen to your databases. So there is a challenge here, which is asking you to modify your code to save the results to your own tables, which we'll go through and to have a think about some of the reasons you may want to save your queries back to a database. So I think, since it's 10 past, I'll give you kind of 5 minutes or so, a few minutes to go through that, and then I'll come back and wrap that up, and we'll then finish off the session. A reminder of the course feedback. I'm sure I'll remind you again when we come back in 5 minutes, but if you find yourself with a couple of minutes, not much to do, we'd really appreciate if you were to fill that in. But I will send this here, and yeah, we'll come back in just a couple of minutes to go through this. So Lorenzo, index is, basically, so it's not a table. So IX Surveys 2002 index is not a table, it is an index. So they're used to retrieve data from the database very fast. So you don't need to be concerned about them as a user using the database. It's clearly something that Pandas is automatically creating when you save the new table. But it basically speeds up the searching and querying of that table to make it faster. It does, like as always, as a trade-off, it does mean updating the table is slower because you've got to update the table and update the index. I've not used indices in SQL myself, but that's what they're for, and you can delete them if you don't want them. I don't know whether you can get Pandas to make it so it doesn't save it, but it's not something you can ignore it. It is just something that Pandas automatically created to make the searching faster, basically. Oh, yeah. Okay, we should probably go through that exercise. I just put it in the chat. You can stop Pandas creating the index in the 2x SQL if you set index to false. That will stop it creating the index. If for whatever reason you would write it, yeah, you don't want it there. Okay, so to go through the challenges, fairly straightforward copy of what we were working on previously. We've got our connection, and then when we created our new data frame up here, oops, we'd just read it in, so df dot read SQL query. So that will use our query that we defined earlier. Do need to pass it the connection. So we've got our data frame, and then we can do df1.to SQL new table 1 column, and I won't bother specifying if exists because it doesn't exist. Yeah, and then again, if we were to then show our tables, we've got our new table 1 and obviously the index it's created, which if I say go to new table 2, the index equals false, and then run the same thing again, we can see we've got our table 2, but we don't have the table 2 index created. Cool. So I think that goes through that exercise. So then they're asking the question of what are some reasons you might want to save your results back to the databases, some of the reasons you might avoid doing it. So one of the reasons you might do it is if your database is shared and it's got common queries or data corrections, and you might be that you want one person to do those corrections or to do those queries, save them back to the database, then everyone can access them. Instead of having everyone doing it themselves. You might, however, want to avoid doing it if, say, the database is from a kind of authoritative or trusted source, or potentially version controlled, or there's restrictions on who can or can't write it to it because it's used for some particular maybe sensitive thing or whatever. It shouldn't, for whatever reason, it shouldn't be modified by users. Instead, it might be more appropriate to save the query results to a new database that you can then do your downstream work on. So as we did before, where you can create a new database file by creating the new connection and then saving your table to that connection. So yeah, so main points, we can interact with SQL databases using Python. It's interoperable really quite well with Pandas. And we can you could also use this to transfer between CSV and SQL because Pandas can read both and can output to both. I think we'll end the course there. I hope it has been useful. If anyone does have any questions or anything related to the course or your own thing that is somewhat related you want to have any questions about or anything like that, I certainly will be around for a little bit longer. Very happy to answer any questions. But other than that, I hope the course has been useful. Yeah, I don't think I have anything else to add. Thank you all for attending.